this session is about how we can create higher quality software. We're going to, obviously the tools that people use will come up, and you'll hear a lot about the tools, but we also want to get some of the higher level stuff in terms of how you can organize the organization so that you can make the code better quality and tackle the technical issues from that angle as well. And we'll also talk about some of the challenges that come up, but I think that's where you, the audience, and your questions are going to help us enormously if you can tell us what are the challenges that you are facing so that you can leave here and you can go away, hopefully, and have some idea about how to set up your own automation department to make code better quality or improve the one that you've got. I forgot to mention, I currently work at a small startup, but I previously worked at Netflix. And so one of the things I was asking myself as a question when I was thinking about this panel was, how did Netflix succeed from going from a handful of devices and mainly manual testing in 2009 to literally hundreds of devices and mainly automated testing in 2011? How did they achieve that successful transition and create really high quality software? And the answer that I observed there was an initial focus on the code quality itself. So identifying those core libraries, instrumenting those core libraries, and then adding automated tests to test the hell out of that core library. And that may seem a bit like a chicken and an egg thing, because obviously you create the automated tests to improve the quality. So if you have to start by improving the quality, then there's a bit of a chicken and egg thing, but you do have to start somewhere. And what I saw there, once you had that core library that was heavily tested, it was kind of like if you build it, they will come. Then developers from other teams started to want to use that library. They wanted to generalize it. They wanted to throw away their custom pieces of code and put their code in the core library because they've had confidence when they were using this core library that it was high quality, that when they made changes, they could very quickly know whether something broke. So what you saw was this gradual, the core library grew and grew, and more automated tests got added so that so from this core, you just grew out into the larger organization, and soon many teams were using automated tests, and you saw this rapid transition to an automated test environment. And with the success, the graph there shows the rise in API calls from all these devices that are out there. So again, a good example of how to switch to better quality code through automated testing. So that was my take on the question. And with that, I'm now going to switch it over to Stuart, who is going to talk about his take.
Okay, thank you very much, John. So good evening, first of all, and thank you for bearing with us. This is quite a technically challenging subject, and at 5:10 in the evening, of course, it's a challenge to make sure it sticks with everyone. So with that in mind, I thought I'd introduce, by couching what is quite a technically dry subject, in terms that everyone will be familiar with. So, Stephen Covey and the 7 Habits of Highly Effective People. Habit number 2, of course, is begin with the end in mind. That is to say, we should all visualize our life, our business goals, and think about what it would look like. Think about concrete criteria by which we would judge success or failure. And start with every day in mind with that concrete fixed set of criteria. So since everyone is largely familiar with these concepts, I thought I'd begin by couching test-driven development in terms of this second habit, because TDD, or test-driven development, is little more than beginning with the functionality in mind. It's TDD, it's habit 2 applied to software. So we've heard an awful lot today. I think I counted about 17 different mentions of the word feedback from tests. And we're all concerned with giving developer feedback from the test. But what do we mean by feedback? Well, I'd like to introduce a slightly different take on it, because the flavor of feedback we've been talking about all through today has been about red, green, passing, failing, shippable, potential error condition. And that's definitely true, and it's important, and it's why we need automation. And that's why we've been talking about automation. We've been talking about the tools, been talking about JUnit, RSpec. You heard there we were talking about Cucumber and some of the work that Cheesy's doing there in the page object model. It's certainly important to be able to deliver that kind of feedback in a fast cycle. But why? Well, to figure that one out, we have to consider 2 different types of feedback. There's that first one, regression feedback. Did it pass? Did it fail? We get that feedback at a particular point in the cycle, which is when we run the tests, either in the developer's IDE or at some point through the CI build process. And it tells us whether we broke something. But there's another more subtle and often maligned and neglected aspect to test-driven development, because test-driven development is not the same as testing. It is not the same as test automation. It is not the same as unit testing. Test-driven development, as implied by the word driven, is about using the tests as design tools and getting design feedback. So how do you do that? Well, maybe touch on that slightly later. But when we think about design feedback, it comes in an entirely different cadence than the type of feedback we get through regressions. Regression feedback comes when we run the tests and focuses on the fundamentals of, is it red, is it green, did it pass, did it fail? Design feedback is somehow less tangible, less easy to pin down, because it depends upon the visceral impact of the code upon the person consuming it. It's about feedback when you write the tests, delivering you feedback about the design of the thing under test. And it basically answers the question, are we making brittle software? Now, why is that important? There's been an awful lot of talk about continuous delivery. And there are theories around if we throw enough compute hardware or enough specialized techniques at our build pipeline, we'll magically enter into a world where trivial changes or any change can be committed, and then within 15 minutes will be visible in production. Those of you who are in a position that you're moving towards this would do well to consider how your development teams would respond to such a scenario. Would they feel comfortable with the idea that the code that they're about to commit will be live in production as long as their tests turn green? Most likely not. Most likely not. So there's that aspect of, to what degree do our existing tests help constrain our software, document our software, and give us the ability to flexibly change our software? Because the brittleness aspect is what we try and counter when we do test-driven development. We take design feedback at the point that we write our test against the nascent code that we are pushing out through that test. And at that point, we're able to say, oh, you know what, the setup for this test is too long, it's too cumbersome. I didn't see how I now am coupled to this database or this runtime component. And you're able to respond to that by adjusting the architecture and design of the software under test. I believe that as a software industry, when we move towards continuous delivery, this is going to be an imperative that increasingly affects our enterprises. The need and the ability of our organizations to drive software using tests as design tools. And that tests deliver the greatest value when we as an organization respond to both types of feedback, not just the red-green, and certainly that's important, but also the design of the thing under test. TDD is nothing more than habit number 2 applied to software. And it delivers software that responds to the need for frequent delivery.
Yeah, so this is a senior group. All of you manage large teams. So I wanted to share my point of view on a topic around just how to organize your teams to ensure that you get the best results. How do you make sure that you organize your teams to make sure you get the best quality code? So, and there are questions like, do you centralize your QA team? Or do you have, QA engineers who are interwoven with each of the engineering teams? How do you do that? Do you want to have dedicated QA engineers, or do you want to have developers who have, responsibility for QA as well? So those are all questions I'm sure, we ask ourselves quite often. The quick answer, and unfortunately, the obvious answer is it depends, right? There isn't a one-size-fits-all answer for these questions. And one framework that I've used to think through this question is this one that you see on the slide here. And my guess is you guys have seen this or different versions of this testing pyramid. And depending on your business, depending on the size of your team, the maturity of your team, you could use this framework to think through and come up with the answer. So here, obviously you have unit tests that give you the maximum coverage. It gives you, the best chance of uncovering defects early in the cycle. Then you have component, integration, API, and then, your UI tests. If you're a small team, you have 3 to 4 developers, there's no question of having a centralized QA team, right? And in those sort of situations, you have the team that's responsible for testing up through the stack. So maybe one thing I could do is just share some examples of how we do it at Lithium. So that's the company I work at. And we actually have different variations of how we are organized based on the specific team and their need. So we recently acquired Cloud. Now that's a consumer-facing site, and it's staffed by a couple of small engineering teams, right? So there isn't a concept of a centralized QA team. So there are developers / QA engineers on every team, and their responsibility is to make sure that they develop and then also do the testing that's required, right? So that's one group. Again, consumer team, they want to get stuff out quickly, and they have the ability to roll back, and they're optimizing for speed, right? So that's one group. So based on that, everyone has responsibility for QA as well. We have another team which is working with a older code base, and they have some tech debt and some testing debt that they need to pay off. There we have a different organization. There we actually have a mixture. We have, each of the engineering teams, they have QA engineers on those teams as well. So when they're putting out new code, they're making sure that they're adding unit tests. They're adding all the other tests on this diagram as well. And there are QA engineers who are focused on adding automation on the top level, so UI automation and API level automation. And then there is a centralized QA automation team that's focused on making sure that we catch up and pay off the legacy testing that we have. So we have that model as well. And my guess is if you're a large team, that's probably the scenario that you're facing as well, right? So that's a good model to think through. And then there is a third group where it's relatively new, and we said we're going to start with the right model in place. So we have, they don't have a centralized QA team. There's one team. Each of these engineering teams have QA interwoven in those teams. So just wanted to share those thoughts with you guys.
Hello, everyone. So I'm from Pinterest. So I manage the internal tools team, which includes developer tools and the internal business tools. So today I want to show you how we do integration testing for our Pinterest website. So, we want to move fast, and every day we do 2 deploys to our website, which is very frequent. And we used to do manual testing to ensure the code quality, to ensure our core features are not broken. So this is very time-consuming and very easy to introduce mistakes because of human mistake. So that's why we created this integration testing framework. So this picture shows you the pipeline of doing integration testing on Pinterest. So whenever an engineer checks in code into production, it will trigger Jenkins' job to build this change into a deployable format. Then Jenkins will automatically trigger another job to deploy this change into one of our testing machines. So you can imagine that we have hundreds of check-ins every day to our master branch. Then each one will trigger such a job. Then we must have multiple testing machines to run this test in parallel. Then whenever deploy to a testing machine finishes, then a testing agent will be invoked to run all the integration tests against this newly deployed host. And if there is any test failures for our integration tests, then a notification will be sent to the person who broke this test, together with a very detailed testing result, which shows you many useful information, like the stack trace of the failed integration test, as well as the steps to reproduce this test failure in your own developer machine, and also the screen snapshot that shows you the scene of failure when a test failure happened. And this is very useful for the engineer to visually identify the root cause of the test failure. So together with this, so the engineer will be able to quickly identify the root cause of test failure, and either they want to fix this change, or they want to say, okay, so probably some UI change makes this test not valid, then they will notify us so we can make a test change to make this work in the future. So And also, you can see from this picture, we don't run this test against just one single web browser. Instead, we run this against multiple combinations of operating systems and web browsers. So we do this through Selenium Hub. Then we run this against more than 10 different combinations to cover our most use case. So this ensures us to catch the very tricky bugs that caused by the incompatibility between different browsers. So with this testing framework and also the high test coverage of our core functionalities, so when we do deploy, our engineers are very confident that their changes are not going to break our most important features. So this is very helpful for them to just focus on implementing the business logic so that we can have better productivity.
Hello, I'm Mangesh. I'm leading the location software team in CSR. I wanted to share some thoughts about how we would want to, or perhaps like to, integrate multi-level testing. There has been quite a bit of discussion in terms of unit testing, component level testing, subsystem testing, system testing, integration testing, so on and so forth. And the traditional thoughts is that those tests are quasi-independent. But in reality, all those tests are linked together through the overall system architecture of the system. So to move along those lines, the first thing to consider is exactly what is the philosophy of an automated test structure. And generally, the way we see it is we think of an automated test structure as a blocking mechanism for changes. A change is made, it gets checked into the software baselines. An automated test is run, and the test decides whether it passed or failed. So that's more of a blocking philosophy for test automation. I think it's worthwhile to consider more of a collaborative philosophy in automated test infrastructure and automated test architecture. And what I mean by collaboration is the philosophy would not really be in the context of an end test which says yes or no, but more in the context of helping the developers either to debug their software or perhaps, as was mentioned before, to provide even design inputs. And to be able to do that, there is quite a bit of integration possible in terms of running tests with different, perhaps, sequences or perhaps optimization criteria. Traditionally, when we think of automated testing, the tests generally tend to build up very quickly, and the testing time increases substantially over new features, new additions, and so on and so forth. And one solution to that generally is agreed to and accepted by a lot of organizations is to have a multi-level test suite where a quick-fire test suite will check out the basic functionality, a more detailed test suite will check out more detailed functionality, and then perhaps a final long test suite that will run a whole series of tests in a particular sequence and provide feedback.